Hello everyone, my name is Mr. Power, and for Code Week I went to some schools and we looked at using VEX VR as a way of learning coding. So for any schools that missed out, or if you are a teacher or a student in the school and you want to look over the lesson again, learn a bit more, this video is for you. So we started off by looking at robots and their nature, a discussion around robots, what they do, how they work, and we discussed in particular around toy robots and how you control the robots using a controller. So a lot of students are familiar with this, but the problem with controlling a robot is it's not very useful for humans to be standing there controlling robots trying to do tasks. It's much more useful if we can instruct them and tell them what to do, and we do that through using code. So the idea of this lesson is to get the students instructing a robot using code to perform a useful task. And in this case, you'll see the worksheet here is about a castle crasher. It's knocking down 5 castles in this play area using this virtual online robot from VEX Robotics. So the VR VEX tool is a free tool. Works on the cloud, so it works on Chromebooks and laptops. No, you don't need to install any software. So a very nice way for schools to get into robotics without having to have any investment or complicated equipment. So to get to the VEX VR site, we type in vr.vex.com in the address bar, or if you Google VEX VR, it'll come up as the top result. Now you're given an option to log in if you wish, and in this case I'm going to log in because I'll be giving the schools a different code where they can use to submit their work. You can continue without the code and it'll work fine, but if you enter the code it gives you the option of submitting the work and getting a certificate for your participation in this Code Week activity. So we hit continue to free, and we're going to go to file and we're going to go to new project. And this gives us all the different arenas. So the one we're looking at, as per the worksheet, is the Castle Crasher. And when we open that, you'll see that the playground will load, should load. When I hit play, it will load anyway. So there you go. So there's the arena. At the moment, we're looking at it in an aerial or top-down view. But you'll see there's little cameras down here. We can do a first-person view from the robot's eye view. We can do a third person as we're standing behind the robot and go back to the aerial view. So our mission is to knock down all these castles. And the way we do it, and if we look at the worksheet, we start looking at the playground itself is 2,000 millimeters by high by 2,000 millimeters wide, and the robot can turn using this degree system here. So it's facing upwards of 0 degrees. So a 90-degree turn will turn it left or right at 90 degrees. So we're going to look at how this works in practice here. So if I drive forward the default, which is 200 millimeters, you'll see that it doesn't get very far. Given the arena is 2,000 millimeters, the students have to think about maybe going a bit further. So if I went to 1,600 millimeters, you'll see that I successfully knocked down the first castle. Okay, so we'll go back to the aerial view and see. So now I might want to turn right for 90 degrees. So a common mistake might be to bring in the turn right block, but that will just make the robot turn and not stop. So if I turn right and I drive forward, if I'm in the center, you could do trial and error, just trying numbers, or you could work out if you're in the center, it's about 1,000 meters to the edge. It's 1,000 meters each direction if you're in the middle of the screen. So let's have a look at this. For the younger students, they can just try different numbers and see what works. So now I've successfully knocked over 2. So I'm going to turn right and I'm going to drive. I might want to pull it in a little bit there because it's gone maybe a bit too far to get the next castle down at the end. And I'm going to go maybe 1,800 millimeters. I can't remember offhand what the exact numbers that work here are, but we'll give it a go here. And hopefully I should knock down the third castle. Brilliant. Okay, I'm gone a bit too far there, so I might bring it back to 1,600 before I turn right again and drive forward again. And that should be 3 of the castles knocked. All going well. Yep, and just to get the last one there, I might need to go a bit longer on this one, I think. 1,700. I think this should just about do it. All going well. Here we go. Da-da. Yes, and that's the last castle knocked. So that's the task complete. Now, if you wanted to impress by doing a bit more, you could look at into using maybe less blocks. So there's a repeat option here, and you'll see that the last few commands I've done are essentially the same thing over and over again 4 times. So if I just get rid of those and I say repeat 4 times, turn 90 degrees, and drive 1,600 millimeters, you'll see you don't need to do this to complete the task, but it's just a nice way of showing students how you can use that repeat block to make life a bit easier and have less code. Brilliant. Now the last thing we can do, if you want to learn the full kind of range of of blocks for this task, there is a drive and turn velocity, which if the students are doing a lot of trial and error, this will make the robot drive faster. So we'll do a first person on this one, or third person, sorry, and see. So we're going through one. We've got the next castle, got the third castle, and the fourth castle. Oh, sorry, that's the fifth castle there. And that's all 5 castles successfully destroyed. Now, let's share our project. So to hit share, I'm going to put in my name, Mr. Power, Castle Crusher. And then I can hit download. And if I've put in the class code, I get the option to share it online. And you'll see there it gives me a little printable page of my Castle Crusher outcome and my code that I've used. So I hope this is useful, and you can log on to VEX, and there's further lessons that we'll be doing as part of the outreach program. Thank you.